All right, so the first thing we're going to look at is different styles of wiring your security system. We're going to look at the contacts for the actual inputs that are going to detect whether or not there's actually an alarm occurring or what the situation is. We're going to do different styles of wiring and whether or not it has a resistor or how the resistor is placed. And this is going to be our handout, and we're going to do a demonstration showing you these different scenarios. The first one is going to be a non-supervised circuit. Second style is going to be a supervised single end-of-line resistor. There's resistors at the ends. And the last style is going to be a double end-of-line resistor. So you got a resistor at the end, just like the other one does, but then each device has a resistor as well. And we'll see how they affect and which one provides the least amount of security and the best amount of security. All right, so what I've laid out here for us is an example of this wiring. I only have one device instead of three, but it still is going to give us the same impressions. So here's my security panel. So let's say zone 2, whatever zone you want to call that. It uses two wires. Notice I used the yellow and green wires, and I saved off my red wires. Usually we want to use a 4-pair conductor. So this is a 22-4. By utilizing just the yellow and green as my zones and save my red and black, for future, if I change this device out to something that requires power, I can just undo the red and black wires and then I can add power to my device. In this case, it does not require any kind of voltage to actually operate what we're going to be doing here. All this is going to do is verify that this is in the position as being closed. So what is my meter seeing? So right now I have it closed. As I put my meter on there, right now it's seeing a little bit of ohms on there. And once I open up the door or the contact, notice how it says open loop now. When I close it back, the contact shows being closed again. Inside is a little reed switch that basically is able to tell by magnetic field how close this magnet is to this device. When it gets close enough, it closes that little switch inside there and it says, okay, we're going to allow current to flow through my device and back. So the way the monitor verifies the status of this is it sends a small little amount of current through here, and back to the source. And it verifies the whole time by sending a small amount of current to let the panel know what the status of that door is. So for example, in this case, I put my meter right here. Panel's reading and saying, okay, what's going on? It sees resistance because the conductor has resistance in it. Open the door. My panel recognized that as being the door is open. It'd go into alarm. If it was set to be an alarm, if it was set to be just a normal day, nothing happening, the arm's not turned on, I open the door, it'd say zone not ready, zone 2 not ready. Close the door. Zone 2 is now secure. Okay. So our first example here is what happens when I opened it. That's what we just did. What happens when I open it? We see open loop. All right. Close my door. Next scenario says, hey, what happens if I short it? Okay, I want to short my contact here. No significant difference as far as my reading at my panel. But now if I open up my door and then I short it, notice how the resistance is still there. Even though my door is open, the security system has no idea that it has now been left open. So if I came in there during the day and I short out that door contact so I can come back later that night, well, this door looks like, as far as the panel is concerned, zone 2 would say, everything's fine, ready to go. We'd secure it, go off, go home, do whatever we're going to do. And that door is now left unsecure. Somebody can come in there, open that door, and we would not know that they have entered. That's an example of a non-supervised circuit. Our last scenario to look at is what happens if I come by and I open the circuit? Let's say I have a wiring issue. Somebody comes by and he gets caught on it, accidentally cuts the wire, or a construction worker comes out there and they have damaged my wiring. So we're going to play a scenario. We're going to take out here. We're going to go up to my device. We're going to put in a false open wire. So there we go. There's my open wire. Okay, my conductor now has been removed. I've caused that fault. We're going to take my meter, secure my door, put my meter on there, and it's going to continuously show an open loop because the loop is open. No matter what I do with my contact out here at the end by my door, I'll continue to have an open loop. So in this scenario with an open wire like this, the panel is always going to say zone 2 faulted until it actually gets repaired. So if I wanted to secure my building, I could not secure my building with it in this current status and have that door actually secure. I'd have to bypass that zone, which would allow that door now to be accessible by people we not want in our building. So you always want to make sure you repair any zone that says zone faulted. In this case, that's what happens. It's non-supervised, the wire's opened, and until that gets repaired, this zone is not being able to be monitored.